Decoding ASCII, the foundation of text encoding. Imagine a world where computers could not talk to each other. No emails, no websites, no text messages. Communication chaos, right? Thankfully, we don't have to live in that world, thanks to the silent hero that bridges the gap between humans and machines. ASCII, the American standard code for Information Interchange. Today, we are peeling back the layers of this remarkable standard that made computers fluent in text. ASCII is like a Rosetta Stone for computers, mapping characters, letters, numbers, symbols to unique numerical codes. These codes ensure that computers can store, process, and share textual data in a standardized way. Without ASCII, your hello might not look the same on another device. Character set size. ASCII originally included 128 characters using a 7-bit encoding system. Later, an extended version expanded this to 256 characters with 8-bit encoding. This provided enough room for basic letters, digits, and symbols, perfect for early computing needs. Purpose. ASCII standardized communication, ensuring characters were encoded consistently across platforms. It becomes the universal translator for text in computing's formative years. Encoding in action. Each character is assigned a unique integer value. For example, A equal to 65, B equal to 66, small letter a equal to 97, space equal to 32. These numbers are the foundation for how your keyboard inputs get stored in memory. ASCII code falls into 3 categories. First one, control characters, 0 to 31 and 127. These are non-printable characters used for controlling text like 0, null, no operation, 7, bell, triggers a sound like a bell. 10, line feed, moves the cursor to next line. 13, CR, carriage return, returns the cursor to the start of the line. Second, printable characters, 32 to 126. These include letters, digits, symbols, and white space. For example, space equal to 32, A equal to 65, small a equal to 97, 0 equal to 48. Third, extended ASCII, 128 to 255. This range was introduced to include additional symbols, accented letters, and graphical elements. Examples. Here's the magic of ASCII. It transforms what we see on screens into numerical values that computers understand. Let's break it down. When you type the letter A, the computer does not see A. Instead, it sees the binary equivalent of 65. That is 01000001. Similarly, when you type 1, the computer stores it as binary 00110001. Even words are encoded this way. For example, the word hello becomes H equal to 72, E equal to 101, L equal to 108, again L equal to 108 and 0 equal to 1111. Convert it into binary. ASCII is the translator that makes this seamless. ASCII is not just history, it's still everywhere. Text files. ASCII stores plain text in files with extension like .txt. Programming languages like Python, C, and Java use ASCII for string manipulation. Data transmission. ASCII ensures reliable communication between devices such as keyboards, terminals, and printers. Programming. ASCII codes are vital for string operations, encryption, and user development. Networking. Protocols like HTTP and SMT rely on ASCII to send text commands between systems. From your emails to the websites you browse, ASCII is at work behind the scenes. But ASCII is not perfect. its limitations have led to newer encoding standards. Limited character set. Original ASCII supports only 128 characters. Great for English, but insufficient for other languages. Extended ASCII expanded to 256 characters, but that still left out many global languages like Chinese, Arabic, or even our Malayalam. Replaced by Unicode. Enter Unicode, which supports now over 155,000 characters, covering nearly all languages, symbols, and even emojis. Unicode with its UTF-8 encoding has become the modern standard for global communication. ASCII was the spark that ignited the era of digital text. While Unicode now carries the torch, ASCII remains its foundation. It's amazing to think that every message, every line of code, and every file you save owes its legacy to this humble standard. Next time you type a letter or send a text, take a moment to appreciate ASCII, the language that made computers literate.